Hello there. Today I will introduce to you competitive programming problems as well as the UVa Online Judge and online resource for practicing. If you're unfamiliar with competitive programming, it is the solving of difficult, often algorithmically oriented problems in computer science. It's generally done under a time constraint and can be a huge amount of fun as a hobby. As a plus, it's also a nice introduction to programming with a smooth learning curve. UVA is an online site with nearly 5,000 problems where you can submit and get your code judged automatically on whether it correctly solved the problems. These problems range across all types of algorithms, many of which you may learn in the future, and it's a great site for beginners, especially when paired with UHunt, a third-party tool designed for UVA. Today I'm going to show you how to solve your first problem on UVA called problem 11799. You can find the online judge by going to uva.onlinejudge.org. You should create an account and then you can go to Browse Problems and find problem 11799. If you don't have an account, click register right here. If you have an account, feel free to log in. Go to Browse Problems, Contest Volumes, 11799. So that'd be volume 117. And you can go down here and you can find the problem we'll be solving today, And if you want to look into UHunt, you can go here and search for 11799. Search and then click on the link. And it takes you to the exact same page as if you clicked on this link. So the basic structure of a competitive programming problem is going to be some sort of description about the problem. And so this kind of gives you a basic description about the task you'll be asked to implement and some information you may need, background information, etc. And also some backstory, which is unnecessary, but it's important to read it all, even if it seems a little unnecessary, because you may miss key information if you choose to not read it. And so then we have an input description, which describes how the input will be given to your program. And so the input will follow this exactly. You won't be asked to use an invalid input case. And the output is what your program must output after taking in that input. And they also will give you a sample input and sample output in order to test your program. And just because it works on the sample input does not mean your solution is correct, but it does allow you to test to make sure you're not missing basic cases. Sometimes the sample input will be helpful, sometimes it will be very basic cases and not test much, which is why it's important to also design your own test cases. So in order to begin solving the problem, it's a good idea to install an editor or IDE. I'll be using Sublime Text 3, but you can find other editors online. If you're new, I would recommend IntelliJ Java IDE by JetBrains. Let's begin by reading the problem statement. You would like to take a moment to pause the video and read it, that would be good. But I'm going to assume you've read at least the input statement and have noticed some of the key information. So if we start reading, we can see that we're going to be given some sort of list of student, right? So we're going to be given these events. And each event, there's n students. And so they assign n as the number of students. So we know the number of students is somewhere between 1 and 100. So that helps you know what kind of input your program will have to deal with. Like how big do you have to deal with, what kind of numbers you have to deal with. Do you have to deal with negative numbers? Obviously, number of students, that doesn't apply here. But we know we don't have to deal with big numbers. 100 is pretty small for a computer. We also, given the speed of every scary creature, you're to find out the minimum speed that the clown must maintain so as to not get caught. And so if you spend a minute thinking about it, you realize that the clown only has to run faster than the fastest person, or at the same speed, and they will never catch up. So looking at this list of students, right, we have 2 test cases, as described in the sample input, and then 5 and 1. And so we see 9, 3, 5, 2, 6 are our students, and then 2 are our students. So we see that 9 is the fastest, and 2 is the fastest, and we output each one. So you have to create a program that does this operation, takes a list of numbers, and converts it to the largest number in the list. We're given information about the size of each student's speed, and we're given the total number of test cases. We're also asked specifically for the format, and it's important to follow this format exactly, as the judge will diff compare your output, because it's automatically judged. There's no room for error. If you get it wrong, you get it wrong. There are other verdicts you can get back, such as runtime error if your program crashes, or time low exceeded if your program is too slow. Here it'd be difficult to come up with a slow algorithm, but for some problems, the fast algorithm would be difficult to come up with as opposed to the slow algorithm. So we'll be using Java, and we'll help you code through this one, and we'll submit it as your first problem, and then I'll leave you with one more problem for you guys to solve. It will actually be a bit easier than this one for you guys to solve on your own. So I'm going to open up my text editor. I'm going to make a new file, and UVA requires that you name your files main.java if you're using Java. If you want to use one of the other languages supported, such as C++ or Python, feel free to go to the UVa page and read about how to do that. So as with Java, we must create a main class, right? And so they require the class to be named main because they need to be able to compile it, and their system expects a main.java file. So we will comply with that. We will need our main method, which is normal for a Java program. And so we're going to need a way to take an input, right? Because every competitive programming problem is going to have some sort of input, and your program has to do the output, right? And if you can't take input, you can't solve any problems. So the start is taking input. This is one important thing you have to learn as a beginner. So in Java, we have a class called scanner, allowing you to take input. So we're going to use scanner. We're going to name our scanner. Let's call it scan equals new scanner. So we've created a new scanner object, and inside of it, we must tell it what we want to read from. And so UVA requires that you read from standard input. So this would be like console input. So we can type in system.in. And so in Java, system.in is just standard input. So it's what you type on your keyboard, and the program will read it. So we can import java.io and java.util. Util is what contains scanner, so we can import everything so we have access to it. And so this includes a lot of different classes, but many of them will be useful. There's plenty of data structures and algorithms present in these libraries, and so that's why we choose to import both. Next, we have to follow this import format and take it in exactly as it is read. So we know we're going to be given one number at the beginning called t, and this is the total number of test cases. So we need to create a variable, obviously, for the number of test cases. So we can start by creating a variable, right? So I'm trying to think about this in my head before you start coding, because you got to kind of think ahead, always one step ahead of what you're going to do, so you don't like go down the wrong road. We're also going to have to take in n, the number of students, and somehow store the list of students. And so if you're unfamiliar with a structure called arrays, we're going to use an array to store a list of students. And arrays are just lists of items, lists of numbers, lists of strings, lists of any object you can think of. So we're going to use an array, and then we're going to have to, we don't actually have to use an array, because you don't need to store them, right? You could also just take them in as you go along, take in 9, take in 3, take in 5, take in 2, take in 6, and never store them. And so that's also an option. And as you get more familiar with these problems, you'll notice that there's always multiple solutions to the problems. So we'll go with the not storing it. So we're going to have to start by creating a variable for the number of test cases, right? So let's go to our main method, and let's call it int, because we want it to be a number, just a integer, test cases. And so using scanner, you have to do scan.nextInt to take in the next number. Scanner also has methods for scan.next double for decimal points, as well as scan.next for strings, and scan.next line. And so as you continue to use scanner, you'll be familiar with those. There are other input classes in Java, but we choose to use scanner. So now we're also going to need a for loop to loop through the test cases. So because we have to do something multiple times, and we want to do the same thing for each test case. So we're going to make a for loop, and let's say int case. So we're making descriptive variable names. You don't have to make them 100% descriptive, but you should generally, actually we can't use case, that's a reserved keyword. We'll do current case equals 1, current case less than or equal to test cases. So we want to go up to the final test case, current case plus plus. So now we have our cases. And in the output, we notice it wants us to print out the current case number. So what we can do is we can actually do that right now. We can print out case, right? So we want to print out the string case plus current case. So add that number plus a colon. And so that will fit. And we actually don't want to put print line because we need the output later. So we will do that. And so now this will, if we were to run this, and so I'm going to run it through the terminal. If you're using an IDE, you can run it however you wish. So we're going to go to my desktop, into the folder that I'm currently in. So we can see here. So if you're unfamiliar with how to do this, don't worry a large amount about it. Okay, so we got an error. And so this is because out is not found. And so you may know that this is really system.out, but Java allows you to import system so that you no longer type that, and we are going to do that. Import static java.lang.system. And so now our program will compile. As you can see, it compiled, and now we can run it. Java main. And so if we type in 2, it prints out case 1, case 2. It doesn't do anything else, right? We still haven't solved the problem, but we got our basic. This will be a common structure for most problems. You're going to have to take in some number of test cases and output some answer for each of them. So we're going to have that kind of outer for loop structure. So if we look at the problem, we're going to be given n and then the number of students. So we need to take an n first. So our next goal is to take an n and then loop through the number of students. So let's see if we can do that. So let's do int students. You can change the name from the problem, so we don't have to call it n if we don't want to. And now we can loop through each of the students. We can use s for student, s equals 0, s less than students, right? Because we want to go up to the number of students. I'm going to go there. So we can get the speed of the student by taking in that. So now we're taking in all of the speeds, but we're not storing them, right? We're just taking in input still. We can test this by printing out the speed, right? This is very useful when solving problems, is to always test them. And test them as you go along, because you may code 200 lines of code and you're like, you run it for the first time and it all fails and it crashes horribly on you. So that's important to test as you go along. So we run it, we're going to enter 2, enter 5, 1, 2, 3, 4, 5 as our speeds, and it prints out all the speeds. Do the same thing down here, 1, 2, 3, 4. So this time we enter 4 students, and we get 4 numbers back. So it is printing out the numbers we give it, but currently it's just echoing them. It doesn't do anything else but just given the input, spit it back at the user, which is not a very useful program. So now we need to actually calculate our answer, right? So we can make a variable and let's call it, ants for answer. Or we'll do max speed. That's a bit more descriptive than answer. And so we know the lowest a speed can get. This is always important to think of edge cases, right? So normally you would want to think like, what could break my program? Well, if we pick 2 as our lowest speed, right? We start at 2. We just assume 2 to be the start, and we look for maximums. What if there's only 1? Then we would be below 2. So we need to start lower than the lowest possible speed because we need to change it as we go along. So we can actually start at 0 or 1 and we'll be fine. But it's always important to think about those edge cases before coding. So if we start here, we can start our max speed at 0. And so you're going to use an if statement. And if speed is greater than max speed, then max speed needs to change. So we can change it to speed. So now we can delete our output, right? Well, we can also just leave it there, but comment it out. And so this is a useful trick for when you're debugging and you may want to suddenly get the output back so you can figure out where your error is. And so most of the time you won't code it right the first time, and so you're going to need to add some print lines, debug, figure out what the output is supposed to be, and trace through it line by line until you get something you didn't expect, and then figure out where that error came from. And so that's a pretty common strategy for like fixing your errors in your programs, because you most likely will not code it correctly the first time. And so now if we print out max speed, it should work. If we go to our terminal, we can compile it. And so if we want to, we can copy and paste the input instead of making our own input, because earlier we were just typing our own input. Copy paste, and we see it does case 1, 9, case 2, 2. And you can see that it messed up the lines because this is both the input and the output. So we were inputting at the same time as trying to output it. And so we put this inner here, and that's why these end up on wrong lines, because this output got put right in between our input. So even though this does not match, it actually does, because it's only looking for output, not input. And so we actually created a file that stored the input instead, which can be quite useful for solving problems. We can create a file, input.txt, put our input in there, and then run the program with that. We can see that it outputs it, only the output is in the correct format. And so it's important that we have everything on a separate line, as it said, right? It wants everything on a separate line. It wants the case number. It wants the required speed of the clown in meters per second, but that doesn't matter because they're given in meters per second. And we outputted everything with a new line at the end. And so based on convention, you will always have a new line at the end. You won't leave lines without new lines. And so it seems that it works. And we tested it. We could generate our own test case, right? We could do 3, 4, 5, 9. So that should print out 9. Actually, we can make something bigger, 50. Why not fit 50? And so if this works, we should get 50. And we do get 50. So our program is supposed to work on any input they give us. And so that's how they'll test your program. They'll run your program on thousands of input cases to make sure it works on any input, not just a small subset of input, because you want your program to be general. You want it to be able to solve the problem every time. So given any input, it will print out the maximum value. And so assuming we made it correct, we would know that our program works. And so we can go to UVA, the same problem page, and if we click on submit, first you'll have to log in. So if you have an account, log in. Let me see. Should work. If you would like to remember you, click remember me. There we go. We'll have to go back to the problem page. Then go to browse problems, contest volumes, 117, and go to Horodash. And so there's a big submit button up here. We click on submit. It's going to ask for our language, and so we use Java, specifically Java 1.8. Assuming you don't use any new features, you should be fine if you're coding in Java, earlier versions of Java. And then we can select all our code, copy it, make sure we're reading from system.in, make sure we have our main, make sure we're not doing anything illegal. Your code can only use standard libraries. You can't import external libraries. You have to just use whatever Java gives to you to solve the problem. And your class must need a main. If you want multiple classes, you have to do that in a special way. And so we should be good. It compiled on our end, so hopefully it compiles on their end, and we tested our algorithm to make sure we get it correct. And so hopefully our program will be fast enough, correct, and doesn't crash. And so those are the 3 things you're going to need in order to pass. Is it can't crash, it can't be too slow, it can't do anything illegal either. If you try to access things you shouldn't, you'll also get wrong answer. So when we click submit, we can see that it's going to say submission received with ID. And if we go to my submissions, we can see Horodash accepted Java, and it tells us how long it took to run the input. And so the input was probably pretty large. It took 0.1 seconds. For small cases, it would probably take very small amounts of time. And UVA, you shouldn't usually run into issues with using different languages, because the different languages have different speeds. So just use the language you're comfortable with, preferably Java. And so we solved our first problem. And so I will, as you continue solving problems, remember to take the time to read the problem. And it's good to sit there and actually think about the problem before coding anything, because especially with harder problems where it may require a lot of analysis, and your first guess is probably wrong. And so as problems get harder and harder, you're going to run into the need to kind of sit there and think, and just think about the problem and write stuff down, right? This is a very good strategy, especially at a contest. Also, don't look at solutions. That's just a bad habit to build up. It's good to look at solutions when necessary, right? If you don't understand it, it is good to learn from somebody else who understands it. But if you've only looked at the problem for half an hour, is it worth it to go look at the solution? If not, you can always just ask a friend for a hint. But don't just go Googling. You will easily figure out the problem, and then you may feel smart at the moment, but if you saw another problem, you wouldn't be able to solve it. And it is okay to struggle in the problems, right? Most of these problems are designed to be challenging. And if you haven't solved them, and then you won't get that satisfaction in the end. And it's always a good idea to solve problems that you don't know how to solve. Don't solve problems you already know how to solve. Because when you solve problems that you don't know how to solve, well, there's something you can learn. And so that's one of the cool things about pair programming. It shows you what you don't know. And it will usually show up pretty abruptly. You will struggle, but you'll be able to absorb those new techniques as you solve each problem, and then you get to apply them to different problems. And you get to learn from your mistakes in previous problems. So if you want to continue practicing, UVA is a great site to find problems. I would recommend using uHunt, as you can get lists of problems. And you can combine uHunt with a book called Competitive Programming 3, written by Stephen Halim and Felix Halim. And so you can see lists of problems from the books, and you can solve those problems in chapters and topics and read the book, and it goes over different topics. or you can just go down here and it will give you recommended problems to solve based on the number of people who solve them. And it's not going to be good to sort through 5,000 problems, some of which will be completely beyond your level, and so solving ones that other people have solved is a good strategy. There are plenty of other online judges just like UVA and other online contests in order to practice. Some of them include like Code Forces, USACO, etc. I think UVA is a good site for beginners, and you can always go Googling in order to find more resources. And so if you haven't solved this problem on your own, go solve Hordash now. And if you want to solve another problem, and this one you should solve on your own, and if you should be easier than Hordash, right? You can use Hordash as a reference for how you do input, how you kind of do your for loop, etc. So this problem is called Relational Operator. And so feel free to go for it. You can read the problem. It's a very short problem statement, and good luck, and thanks for watching.